afternoon, everybody. For those of you who do not know me, my name is Ali Kujuri, and I'm one of the organizers of this lecture series on behalf of our department and the School of Science and Technology. Let me thank you all for coming to this fourth lecture in this academic year and 103rd lecture in the series when it started in 2006. I should also, of course, thank Keysight Technologies for sponsoring this lecture series since the beginning. I have two announcements to make. Number one, as you know, we'll be having pizza. It's going to arrive at 5:30, right after the lecture. And then also, the next talk is titled Overview of Distributed RF Microwave Filters and Design of RF Systems in the AWR Design Environment by Mr. Drew Fisher. He comes from National Instruments, and in fact, he's a hardware engineer. In fact, some of you who want to go to the hardware field, I think this is a very good, to come here and then hear what they have to say. It's a pleasure for me to introduce our guest speaker for today, Mr. Robert Koslowsky, and the title of his talk is Innovation and Utility in Engineered Solution, the Sarin Story. I bet all of you who every day come can see the Sarin, the logo at the top of the thing at the hall, so he's from there. Mr. Robert Koslowsky spent more than 30 years in the high technology field of optical fiber transmission systems and energy development. His degree in electrical engineering from University of Manitoba enabled him to work at large telecom manufacturers such as Nortel and Cisco and innovate with a number of startups including Sarin, Sarin Systems, Inphase Energy, Elocate, and Sarin. Rob served as an officer of the Redwood branch of the California Writers Club in the mid-2000s and has written on numerous technology and engineering topics. His second book, The Upstart Startup, How Sarin Transformed Cisco in published in 2014, captures the story about the rise of an innovative telecom startup based here in Sonoma County. Rob is a member of the IEEE and the Northern California Science Writers Associations, and he serves on the board of the University of Manitoba USA Foundation. So here is Robert.
Tweak the slides at the end. But as you're looking for it, time out, yeah. So as you mentioned, I'm Rob Koslowsky, and been living here in Sonoma County since I moved here in 1997 to work at Sarin, which has been a blast. But I came here to support the marketing of this new technology back then, but I am an electrical engineering by training. And it's one of the most exciting careers because I got into the fiber optic field at an early age back in 1981. And it was exciting because we worked on the world's longest fiber optic system, which happened to be in Canada, Saskatchewan, doing voice video up between Regina and Yorkton for that customer called SaskTel. Then I got exposed to a fiber to the home field trial, which was also sponsored by the Canadian government in Manitoba called Project Eli. So you get a wide diversity of ways to apply your electrical and engineering working on those kinds of projects. Everything from telecom, fiber optics, voice and data, so it was exciting. And then the other part of it is the engagement with customers. Back then I worked a lot with GTE, which is now Verizon, you may have heard that, US West, which is now CenturyLink. And again, the challenges there were for them in the 90s to, how do I compete with other service providers that are going to try and take my business away from me in places that, like US West territory was Denver, Salt Lake City. How do I protect my customers from going from an alternative carrier? And so we work with them on using technology to make them more competitive. So again, I encourage you, keep studying hard, get your degree, whatever form it is, in electrical engineering, computer science, you name it, and then apply it, and you'll find it very rewarding. This story is about a startup right here in Sonoma County. And the story, oh, the picture blocked it. Okay. The story is actually set in Petaluma. And it's also known as the center of Telecom Valley, because one of our luminaries in the county, Don Green, founded a number of companies in this county and developed that. And it became known as Telecom Valley. Events transpired during 1997 through 2003 that allowed a lot of competition in the industry, that allowed these kinds of products to be built for these new customers. And that was the signing of President Bill Clinton signed the 1996 Telecom Act. There was the rise and fall of the so-called dot-com bust, where there was a lot of internet companies that came and went, but the demand, the relentless demand for bandwidth didn't subside. And then we had the telecom meltdown there, which in 2003, there was a contraction because there was a feeling that there was too much fiber out there. And finally, that's been consumed, and now we've returned to the growth situation. Also, with a lot of the work we did, a lot of my colleagues worked with Saeed to fund and get started this complex so that there could be an engineering curriculum here at Sonoma State University, and supported him. And today, people like myself, a lot of influx of high-tech workers from around the country came, and we've remained in Sonoma County because we love it. The other big thing that happened in 1999 is we had Britney Spears appeared on the scene. We had the Wachowski brothers produce The Matrix. It's now brother and sister pair. One of them had a sex change. We had George Lucas come back that year, and in fact, the Sarin team, we all left work in May, I can't remember the exact date, in May of 1999, and went to see The Phantom Menace. We shut down the entire company, we bought out the theater, and went to see the new George Lucas film, which I guess is now known as Episode 1, I believe. Okay. MySpace was big. Has anyone ever heard of MySpace? Right? Napster and Neopets. So that's the environment. If you could put your head around that, that's where we were in 1999. And yes, engineers do like geeky stuff. So we went to see Star Wars. So this is interesting because entrepreneurs and visionaries, people that you will become or people that you'll want to work for, look for a need out there to fulfill. And what this team in Petaluma discovered is that there was a need for something called multi-service provisioning platforms. All that means is we needed an optical infrastructure that could take a number of service interfaces and transport them across the network. So there was visionaries that identified a need. That'll be an area I talk about. The second area I talk about is product integration in terms of technological advances that allow you to combine different disparate technologies and produce a product. And from the customer's point of view that buy these products, if you have some pretty cool innovation, it'll pique their interest. I mean, probably the best example is my iPhone. Heck of a lot of innovation when this first came out, and everybody still lines up to get them, which is pretty amazing to me. I'll talk about, can an idea and a single product sustain an entire company? And we'll take a look at that. How a product that you produce that a customer uses will attract more users. And last but not least, we'll look at how these MSPPs became a catalyst for the entire telecom industry and look at the impact on industry and, in fact, the impact here in Sonoma County.
You want to go back?
Nope. Oh, hang on. Yeah, I got to go back one, I think. No, that's fine. That's fine. I'm not going to stay there. So what was the problem that the telephone companies focused on or had to deal with in the 1990s? If you look on that slide on the extreme left, there's huge demand. And thanks to, if anyone's ever heard of AOL, it's probably not the, people use Gmail now, but AOL was growing at leaps and bounds. There was like 20 million subscribers in less than a year, in no time. So exploding demand in the access in the late 90s. On the right-hand side of the slide, the established vendors that made optical fiber equipment on the right were producing all the supply. They were building out entire networks for WorldCom, MCI, Sprint, AT&T. Some of those names are you familiar with. Others have disappeared from the market. But the bottom line is lots of demand on the left, lots of supply being built on the right. But there was no one building something to break that bottleneck in the middle. They couldn't get the traffic from A to Z. They couldn't go across the country because you were constrained. So there was long wait times, and it was very frustrating for folks. So that's what Sarin focused on, the metropolitan space. So it was 1997 when the Sarin engineers got together, and this was interesting because that's when this report came out, and said, where are the high growth areas in the telecom market? And they said the highest growth areas were in people doing DS1s, people doing DS3s. And what are those? DS1s, that's just a aggregation of 24 phone calls, 24 voice circuits. DS1, digital signal 1, so that's level 1. DS3, that's an aggregation of 28 of those DS1s, or 672 voice circuits. And that's the area that was rapidly growing. You had 1,100% growth in DS3s. So why not build a product that addresses that high growth area? And that's essentially what the Sarin 454 became, which we'll touch on in a few minutes. So the other challenge that they had at the time was, you know, someone would phone up saying, I need a second phone line. I'm going to, you know, my wife's always on the line, and I'm being stereotypical here, but that is the case in my family. If I need to use the phone, I need a second line. Or if I want to send a fax, I got some business to do at home, work at home. That's back in the days of faxing. You needed a third line. But, you know, those were lines that were added, and then you would maybe use them not all the time. All of a sudden, the internet comes along, and these telephone companies were getting orders for thousands of phone lines in a week. And by the way, a lot of those phone lines were permanently active because people were what? Using the internet. Believe it or not, there really wasn't a widespread use of the internet until the late 90s. And that's what was driving this demand. So Sarin came along and challenged these established characters, as it were. You remember on this right-hand side, the huge supply that was being built. They were investing in bandwidth supply, they being Lucent Technologies and Nortel Networks. They didn't want to change, but they liked building the supply because for them, that was high margin. They were making a lot of money by selling this kind of equipment. As a result, they were ignoring the metropolitan networks, right? There was this bottleneck, and they didn't want to start making different kinds of products for that. And that created an opportunity for Sarin to come in under the radar and build something other than standalone products, other than bitrate optimized products, and ones that use these large cross-connect to move traffics from A to Z. Why not do something a little bit different? This gave Sarin the opportunity. So, what we found is that, let's just listen to the customers as well. They were saying we need to break this bandwidth bottleneck. We need someone to do it, and so we listened to them. We took technology, in this case, application-specific integrated circuits, or ASICs, which you may be familiar with, or FPGAs, and we said, let's try and use those to reduce the size of the product and reduce the amount of power that's needed to run these products. We said, let's do a single platform for all optical bit rates. Instead of having a separate box to do OC3, which is simply 150 megabits to carry 3 DS3s, a separate product to do OC12, a separate product to do OC48, a separate product to do OC182. Let's just do one box that does them all, okay? Similarly, let's have a common platform. Let's use that same box to have different service interfaces. Remember you saw up there the growth for DS1s and DS3s? Let's do that, but also there's something called data that was coming out. Has anyone ever heard of Ethernet? Okay. Ethernet was one of the potential good interfaces to carry data traffic across the network. Back then there was frame relay, ATM, and Ethernet. As you know, Ethernet and packets have dominated since then. But back then, the ability to handle any of those was considered very important. We looked at a distributed architecture. Why have it centralized? Why have to home run everything to one location? Why not do local switching right where the customers may be, you know, having their communications or their internet sessions do distributed? And then have something that can manage the whole thing, one platform to manage it. So this is what we came up with. If you take a look at the platform, and it was very nice, the team rolled in this old ancient version. This is the original purple shelf version. The Cisco version's gone with the Cisco teal blue, but this is one of the original shelves. And if you look at it, this product is about the size of, not a modern day, but an old-fashioned microwave oven. The competing products were housed in 7-foot racks, what I call refrigerator sized. And we could get 4 of these in a single 7-foot rack. So all of a sudden you had the ability to cut the size of the technology that these other guys were making by 4 times. Now, why is that so important? Okay, I'm a telephone company, or I want to compete with a telephone company, and they got to install equipment in, say, downtown New York, where there's a huge demand. What do you think the real estate costs are in downtown New York to get office space, even if you're the incumbent telephone company? 9X, which is now Verizon. Huge. So if all of a sudden you get 4 of these things that do the same thing and more in a urban telco office, all of a sudden you're considered very valuable. And that's what these things did. Okay? So cut the size by 4 times, cut the power in half. So in spite of the fact that it's condensed and generate a lot more heat than the other ones, A6 allowed you to lower the power consumption as well. Okay? And customers also like excitement. They like something new and fresh. If you go to a large customer, they'll say, you know, you're new. Are you going to be around? So you got to give them something to be really excited about and say, hey, I want to try this product out. And so what we did, there's a bunch of world firsts, and I just jotted down a few of them. So for this platform here, we could take any optical bit rate with any service interface, you know, that was available at the time. DS1s, DS3s, all the OCNs, Ethernet, you name it. A distributed architecture that supported in the network multiple rings or mesh topology, and I'll show you what that is in a minute. Integrate the cross-connect, and I'll explain what that is. But before you'd have traffic coming in and out of the box, it would go somewhere else, be switched, and then come back to the box. Why not do the switching inside in the machine here? And so we did that as well. As I mentioned, support all traffic types, voice, video, data. And last but not least, develop a graphical user interface that allows customers to manage the product using the web. That had never been done before. It used to be separate X.25 networks. You'd have to figure out how to get into it, and then you'd manage it on a node-by-node basis using command line language. Oh, horrible. Why not use something like the Mac back in the 80s, 90s, graphical interface, point and click, and make a connection of the circuit from A to Z simply by using your laptop. Okay? And laptops were a lot bigger back then. Okay? But that was the idea, and those were the first, and that's what got us a lot of customer attention. Okay, let's do an example. This is a network view. On the left, here's how the other guys would do it. So it's 8 sites. They needed a box to do OC48, which is a high-capacity system that carries up to 48 DS3s worth of traffic, or 48 groups of 672 voice calls. Or you can stick Ethernet in there, whatever the interface is. But they need a separate box for 48, a separate box for the OC3, a separate box for the OC12, a standalone digital cross-connect. Okay? Why not have that single box that does it all? And that was a major part of our value proposition, was totally upend the economics of the situation by having a single platform that does, can handle all these locations and all these functions. Okay? So not 4 products, but 1. That yellow shaded area, let's zoom in on that on the next slide. And in that slide, you will see that on the left, that's what the traditional guy's equipment would look like at that site we highlighted in yellow. The 48, the 12, the 3, and the cross-connect. It's not quite the scale, almost. That should be a little bit larger because it's one of those yellow blocks is us. So that single shelf can handle the 3, the 12, the 48 by equipping the appropriate optical units. You can see some in here. And this is the 3. I can't read it without my glasses, probably a 12 and a 48. Any optics. And then the service interfaces on the outside, which in this case are TDMs and other OCNs. Okay? So any platform, any rate, integrated cross-connect. With all of this packaging, we were able to get the selling price of the OC48 configuration of that box on the right. The cost so low that we could sell this thing for 1/3 of what the other guys were selling. So they were selling a box, early on it was even more. So early on they were selling a box for like $125,000 in 1998 dollars. We were selling ours for $40,000. Did that catch the interest of the customers? Absolutely. And oh, by the way, not only the hardware, but the software was included. If you bought the product from us, you were licensed. We had an IP address assigned to each product. This has a unique IP address. And you got the software license associated with it. So any updates? Later on, we figured out how to do software download. What a concept to update the system. Apple does that all the time. I'm an Apple guy, I'm not a Windows guy, so bear with me. So that was revolutionary at the time. Who did software updates in this business? Nobody, right? And so that was an innovation as well. So that's what we did. And we got a lot of attention, and it was a heck of a lot of fun. The other thing we did from a business side, so this is the technology, ASICs, integration of hardware and software, putting it as a system, doing all this functionality, flexible configurations. Part of it was we said, you know what are the other guys doing? They're doing 1-year warranties. So what we did, before Cisco acquired us, we said, let's do a 5-year warranty. Why not? The stuff is so reliable. If you think about it, we had 4 plugins that did the OC48 configuration. 4. The competing Nortel or Lucent product had anywhere between 12 and 15 plugins because they had so, segregated the functions, they didn't integrate. So it was low risk to offer a 5-year warranty because they had so few plugins that would fail. They had so many more that would fail. So they had 1-year warranties. So when you're an engineer, it's not just the brilliance in the technology and development, but think about how this might help the people that sell the products make it a better business proposition. And things like warranty and getting the product. We work with outsourcing the manufacturing, and we could get a product to a customer 10 days after receipt of order. Unheard of. Back then, OC48s took 6 weeks to get. And as the market was changing because of Clinton's Telecommunication Act of '96, it was becoming very competitive. You needed to get your stuff quicker before the other guy could take some large customer. You don't want to lose the Microsoft customer in Redmond, Washington. US West did not want to lose them to a competitor like Level 3, which is still around today. Okay? So you would fight very hard to get your stuff up and running quick. All right, let's return to the network view. And even though it's baseball season, we don't want home runs. Okay? We don't want home run connections. Let me go to this one first. We don't run home run connections like this you see on the left. You see the 3-1 cross connect? The other guys had this centralized architecture. You have traffic coming into A, have to go all the way to the cross connect, be switched, and go to B. Doesn't that seem a bit ridiculous? Why not do the Sarin solution on the right? Is if the traffic stays local, why don't I switch it within A and B? There's enough intelligence to know that, so I switched it. So on the left, you also, because they're home run connections, no sonnet ring protection. So if you had a cable cut, right, you lose the traffic. There, if you have a cable cut, it'll go around the ring, right? Very important feature. They had to have the cross connect for that traffic management, as I mentioned. We didn't. It requires a lot more bandwidth. You can see just by the length of the black line how much more capacity I would be using up with a bunch of those on that network. And it required a lot of ports at the cross connect being consumed. So you're investing resources in something to switch it. Why put money into that? Why not pour more money into the capacity and switch it locally? Okay. So that's what we did. Distributed architecture, sonnet ring, or it could be configured as a mesh, which never got to be so popular. Everyone seemed to like rings back then. The switch matrix, the switch, we used less bandwidth, and you didn't need cross-connect ports because we were switching. Okay. We also optimized the sonnet infrastructure. If you take a look at this slide, which is the rack profile slide, if you're a competing vendor, you needed a separate box to handle Ethernet blades. So you'd have packets, Ethernet, it would come out, say, as an OC3, and then go in there, OC3 box down there, then get uploaded to a 48 and out to the network. Same thing if it was asynchronous transfer mode or frame relay. If you look at the Sarin solution, what did we do? Right? We did a different plugin and said, okay, this is the Ethernet plugin, this is the ATM plugin, this is the frame relay plugin, this is the video plugin. So if you wanted to get out, just scale your bandwidth up on the right. You can upgrade in service from a 12 to a 48, later to 192. And to handle that capacity, stick in the blade you wanted, those ones in the red on the right. Okay? Interesting story. Ethernet and IP took off so much, driven mainly by companies like Cisco and a few others, that we actually had working ATM cards. We never released them because the world was switching to IP. This is 2001, 2003 timeframe. Frame relay fell by the wayside, and the cable company said, no, we don't want the video on this platform. We'll do it separately. So as it turned out, we had the video and the ATM designed, and they were never introduced. Instead, we introduced things because storage took off. People needed to store things, right? And so we did fiber channel cards, and then later on gigabit Ethernet. They were introduced on the platform. The other thing I mentioned that was critical was the graphical user interface of the product. And one thing we learned, I think as Steve Jobs at Apple did, is customers don't know what they can have until it's put in front of them. And so yes, we could do all this. This was, for the engineers, trivial, standards-based. It's the alphabet soup of management, transaction language 1, S&P Corp, all that. We could do that, easy to do. But what was different for us and what separated us from the pack was the graphical user interface. We leveraged, it was out a year or two. Brandon Ike invented it at Netscape. It was called JavaScript. So we used that as a basis, and then we set up sessions with each one of these 454s. There was a dedicated processor in one of the cards, and so we dedicated on a per shelf basis with a unique IP address the ability to look at everything going on in that equipment. So we could tell you which ports were active. We could tell you, oh, is there a fault? Something's wrong with the card. We could give performance metrics. So what's important about performance metrics? Then the customer, our customer, could create service level agreements to guarantee, using the Microsoft example, Microsoft, that we will guarantee you this level of performance, this bit error rate, this amount of latency. And so this was a very powerful thing to do. And that's what we did with the user interface on the product. Did customers like it? Yes. We got incredible acceptance with this list of customers on the left. There were different customers, and you can see the ramp up over time. The first systems went in service on November 1998. Cisco acquired us, and we had about 140 customers by 1999. So the uptake was very rapid for us. Okay. We also did this supposition, and we did the math for the customers. I'll tell you the rest of it in a minute, but if the next 5,000, say, OC48 configured systems, and that's directly at our competitors, that's where they were weakest for us. We were really strong at the OC48 configuration versus their standalone boxes. We could save them, for 5,000 NEs, about 3 1/3 miles of vertical space. Again, that's very important if you're a large customer and you got a downtown area. You don't want to use a lot of space. So if you can tell someone you can save 3 1/3 miles of 23-inch rack space, that's a lot of real estate. We did the work studies, and we showed that you could save 1 day per node. So there were 13 people for a full year that didn't need to install anymore. What they could do was either work on provisioning circuits to turn up circuits more quickly and generate more revenue for the company, or those folks, if they preferred, they could work in what's called the maintenance area and make sure customer service stays high by addressing faults, which was easier to do with our GUI-based systems. Our product was really interesting. It took a week to be trained on a competitor's product. You could train our guys in half a day to a day. Very simple and very, it's because of the integration. So we figured about 1,500 people days of training each year, 5 times savings in spares. This is a lot of numbers, but we could save Ethernet ports, and these could then, we could do more Ethernet ports, which allowed them to generate more revenue. Why is that important? It's not the number of ports and the revenue, it's the thinking that your optical infrastructure all of a sudden can be a revenue producer. And that was very novel back in those days, right? Today, the revenue producer is around, oh, my optical product has better latency performance, less delay. So there's people in Wall Street who do these financial transactions, and if you can do yours a couple of milliseconds faster than another financial house, that vendor is going to get that equipment order because they have a better performance and latency. So things have changed from less technology, more business as we do this. This was a survey we did for about 7 customers in 1999. And what do you notice about what was the most popular feature of this particular product that we did? Right? Cost. They love the cost. So that was overwhelmingly in favor. Others were the reduced training installation, as I mentioned. The distributed bandwidth management I showed you, where you don't have to go back and do these home runs. You can switch locally. The space savings was huge, and You notice I highlighted the number one. No surprise, this customer was a competitive local exchange carrier. They were up against the big incumbent RBOX in an urban area. Their number one thing was, I don't want to pay all this money for real estate. I want this small box simply for its size. I don't care, well, they didn't quite say I don't care what it costs, but we could have easily charged them $100,000. Of course, then you get into Robinson, Patman, Axel. No, selling price is the selling price. Space savings, the evolution to go upgrade from OC48 to 192 was of interest to a lot of people. Less spares, which means less inventory for your network, and they love that as well. So that gives you a taste for it. Breakthrough technologies. This one I have a lot of fun with because I read a book in '99, so of course I have it on my slide. Breakthrough technologies, they define as this list on the left, right? And you can see it there. You know, productivity, functionality, make sure the end user can take advantage of it in a meaningful way, and so on. And before I get to the Sarin point, let's just briefly talk about Thomas Edison. Was his light bulb a breakthrough, a technology breakthrough? Right? Absolutely, right? So what was he faced with? He said, in terms of productivity, all of a sudden you can work or play during the day longer. That was huge. Can you read without eye strain? Yes. You no longer have to deal with, in terms of functionality, right? A flickering candlelight or that smelly gas lamp that used to be in your home. So that was huge. In terms of the enabling the user, the wall fixtures and the ceiling mounts where you had candle holders and these gas lamps, you could reuse that to put in, run wires and put in electricity. And in terms of the fourth one, Thomas Edison's light bulb, it was cheap in the long run. You didn't need to buy candles or pay for gas. It was activated, right? How'd you do it? Flip a switch. You don't even think about it. You just flip the switch. It's always available, and then people would go, what else can we do with electricity? So from that point of view, I argue that electricity was the light bulb what optical fibers are to the Sarin 454. They enable each other. And specific for the product, there on the right, is why the Sarin 454, from that, those authors' perspectives, was a breakthrough product. You know, you're increasing profitability, you're integrating, you're doing more functions in the same amount of, in less space than the others. You can fit into their existing networks. They did not have to change, even though there was some revolutionary technology here. The customers did not have to change how they ran and operated their existing networks. Remember, we fit in the easy part, and if you want to try something different, we let them do that with GUI, and that has since taken off. Everyone uses some form of GUI now to manage these networks. And last but not least, we've reduced the cost to operate them, better network reliability, and so on and so forth. So once you have a breakthrough technology like the Sarin 454, you can then achieve what I call as breakthrough momentum. So in terms of the timeline on the bottom here, company's founded, product design, you upend the economics. You got to get customers saying, I really want to use this. The financial metrics are there, now let's give them a chance. Then we optimize the infrastructure. What more can you do? Well, you do voice, you add data, and again, the winner of that battle was Ethernet IP. And then you supercharge capacity. You keep on going. So you go from 12 to 48 to 192. So we supercharged the capacity, just as Cisco was acquiring us. Then you collapse network layers. I don't need to put voice on ATM on this optical infrastructure. Just do voice directly to optical infrastructure, for example. And then ultimately, you introduce extensions of the product. So we came out with things like multi-service switching products. Those platforms are nothing more than an optical cross-connect. Why switch all this stuff electrically if everything's going around at 3s, 12s, and 48s or light? Why not switch light? And that's what has since happened going forward. So once you have a breakthrough technology, you got a breakthrough momentum, what happens? Do competitors just let you do that on your own? Nope. The competitors hate that. They try and stop you. Example. Was MySpace successful in stopping Facebook? No. Was Yahoo successful in terms of search, stopping Google? No. Was General Motors able to stop Tesla in terms of the automobile industry? No. What's really interesting in that one, though, if you think about GM, do you think of GM as an automobile industry? You know, old school? Tesla on Wall Street stock does so well, it's looked at as a high-tech company. Think about that. It's not seen as an automobile company by the financial community. It's a high-tech company. They got GUIs on their, you know, the heck. I haven't driven one. Can't afford one. So there we go. But what did our competitors try and do to Sarin? In the short term, they tried to bundle deals. They had transport and standalone switching. So they would say, buy our switching equipment and we'll give you the transport gear for free. Well, you got to walk away from that deal. We can't give our stuff away for free. You know, you got to pay everyone's salary. They spread FUD, I call it, fear, uncertainty, and doubt about our product. They act as if they knew more about our stuff than we did. So we were busy on the customer engagement side, trying to make sure we got our story told by us, not by someone else. They also dumped what I call legacy products, their legacy products, to kill momentum of this whole new category we define, the MSPP category. They said, look, we'll give you half price on the 48. Just go with us. Stay with us. In a lot of cases, that didn't work because customers knew the game they were playing by them. And in the long term, 2 years later, they all, not a single one did not, they all these guys introduced their copycat products. So we actually were very lucky we got a 2-year head start on those names you see there. Okay? And of course, what was the thing in the long term? Because you had technology, you had the focus on this segment of the market, the overall price came down. Okay? Now, not wireless prices, but if you think about long distance calling and then local calling a decade ago, if you've tracked it, the prices were incredible. It came down. There was MCI, Friends and Family, there's all kinds of programs, and the prices came down. Wireless is a whole other ballgame. Okay, so can a single idea and a product sustain a company? Yes, you identify what the problem is you're trying to solve. You break that down into a set of engineering solutions. You need, in this case, we needed not only hardware and software and its integration, we needed management and we needed business solutions that the customers would resonate with. So the answer is a big yes, that can be done, but it's up to folks that have the engineering talent. For us, and I won't go through all these, well, just quickly, we outsourced the manufacturing. We decided not to invest our earnings in building a manufacturing organization. We hired, in this case, in Southern California, PCB assembly. So we hired people that knew how to manufacture line cards, and they built them for us, which gave us the added advantage of, we told them how many build over time. They held the inventory, we didn't. And when a customer placed an order, we sent them the order, they fulfilled it, and out it went. 4 plugs, a shelf, and you had your order in less than 2 weeks. Typically, you could do it in 48 hours. We also empowered the sales team to close their own deals. What does that mean? Well, in the old days, you had stuff on paper. You had to get permission from headquarters, right? Why not let the salespeople, we equipped them all with laptops, with a configurator for the product, which really wasn't that complex because it's, you know, a few plugins and a shelf. And we said, give the customer a quote on the site and get the order. Now, the biggest problem for them wasn't doing the quote and getting the customer's buy-in. Back then, it was hard to find an Ethernet connection to connect to the internet to send them the quote. That was our biggest problem back then. There was guys running around in the customers' buildings, telecom companies, trying to find their Ethernet connections. Of course, now we got Wi-Fi. The focus and execution of all of the folks involved, that led to financial success, not only for the company, but for the people that use the gear. Okay? And what we found, it's a self-fulfilling circle. You get customers' acceptance, you keep doing innovation, and ultimately they go with you because it's a low risk, because they see what you can do, and it's low cost. It was a no-brainer for them. So in terms of the competitive advantage, what we helped the customers with was let them put in a network that had the lowest cost of raw bandwidth. They had construction budgets. These are built out a year. Sometimes they do 5-year planning. That's gone by the wayside. But if you do a year budget, if all of a sudden you could double or triple your geographic coverage because of the price is so low, you're in like Flynn. It's brilliant. If you can talk to that customer's installation and operations people, and it takes them minutes to install, seconds to point a mouse to go from A to Z and activate service. No truck rolls to activate that service, right? Because you're in front of a keyboard. You don't have to go to each site, you know, configure it with command line language. Go to the next site, configure for a command line language. Know what to look for this site, right? That was very time consuming. So our view was, lowest operating cost, and no truck rolls. Okay? So if you think about it in terms of Sarin as an innovation, as a catalyst for innovation in telecom, we helped to build that momentum in the market. We weren't the only ones. Others came along and did that. We set the stage for high bandwidth service delivery to address that demand. Remember the left side of the chart I mentioned where AOL demand was booming, and then others came on board. There was a whole bunch of other vendors getting into the internet service provider market. We also created a demand for high bandwidth switching in the form of MSSPs. That's the switching platforms. We went to optical cross connects during the 2000s. And then in the 2010s, what's been going on now is more innovation in optical. So I'm really excited you have an optical program here, is you could be part of these MSTPs in the metro and other places where you leverage wavelength division multiplexing. And that's simply multiple channels, multiple colors of light on the same fiber, and those can be combined optically. And that way you can leverage the fiber in the ground without ripping up city streets, just use DWDM. And today companies like Ciena, which used to be a startup, and by the way, Nortel Networks went bankrupt, and Ciena picked up their optical team to allow them to continue the momentum. So Ciena's there, other vendors do coarse wavelength division multiplexing, and then a company here in Petaluma, Sarin, which by the way was acquired by Ciena a couple months ago, I think, they focused on reconfigurable optical add-drop multiplexers. So think about it, reconfiguring your optics to transport traffic. And that's a whole new category that basically replaced the MSPPs called POTS, which isn't plain old telephone service. It's packet optical transport systems. So that's where we are, or that's what's happening right now. And to give you an indication that demand and the access is still growing, I pulled this off the web yesterday because I get this, I subscribe to Fierce Cable. And it says Cox Network's architecture, the chief network architecture for Cox Cable, Jeff Finkelstein, said demand growth on his MSO's network is increasing at an annual rate of 53%. That's still, okay? Now the fastest we could go on the Sarin platform was 10 gigabits, and I brought this 10 gigabits plug-in. So 2.5 to 10 gig. Now this is the early 2000s. Guess where we're at today? 100 gig's been shipping for a few years. 400 gig has been shipping for at least a year. And they're about to release, they're having standards talking about 1 terabit. So this is a dinosaur. And when I worked on it, this was like leading edge stuff. Okay? And most of this card, and the reason it's so heavy, was heat shield. You got 10 gig back in the day, it generated a lot of heat. So this was all, it's not heat shield, heat sink. It's not the Mars lander. It's a heat sink, okay, to dissipate the heat. So in terms of telecom, there's still a heck of a lot going on. It's the same story, just higher bit rate, different service interfaces, different standards on how to manage this stuff. Okay, so what we have here, and I won't go through each one of these because we'll have pizza waiting soon. Sarin was acquired by Cisco the same day that Monterey Networks was. Has anyone ever heard of Monterey? They're in Texas. But they acquired us on August 25th, and it finally closed on November 1st. But what Monterey brought to the table was optical switching. They fit in that middle block you see there. Shortly thereafter, Cisco acquired Pirelli Systems. Their talent is based in Monza, Italy. They supplied the technology to do long-haul networks. Cisco then also acquired Keaton Systems, where there was a flavor of Metro DWDM. And what I'm trying to get across is here, what Cisco did is they said, we're going after Nortel and Luce in a big way. Cisco had no optical. They were all IP, routers, switching. Cisco's IP, packets. That's been their religion. But they got an optical in a big way. It became IP plus optical, and they used the Sarin team in the optical networking group to rationalize all these different products and figure out how we were going to manage the products and the technologies we wanted to keep to service the customers. Okay? And part of the reason you saw that big uptick in customers is the customers said, oh, there's no risk. We can buy the Sarin products because Cisco brings, stability and credibility. They're not going to go bankrupt, right? That was the thinking in 2000, okay? And so what we did as a team was focus on services and revenues to the left, helping customers do a better job at serving their customers. And these, again, are all telephone companies and cable companies, utility operators, long-distance operators. Help them focus on the services, and that's what generates the revenues. Still focus on the metro in terms of growing the capacity and keeping up with the bandwidth that's coming out of the access. And then on the right-hand side, work on this relentless lower cost per bit. If you're sending signals across the plains of Texas, no one's accessing them. So you want to make sure you're sending stuff a long distance, lowest cost per bit. You don't need anything fancy there. Just photons flying across the plains of Texas. So this is what the industry analysts said in 2000. They talked about Cisco had market leadership. Cisco, because they got into optical, was leveraged for future upselling. The big ape in the metro is Cisco. My favorite is, and we worked hard on this, is that we actually sold in the year 2000 the most OC48 equipment of any vendor in the world. Our stuff, we did over $1 billion, which if you priced it like the other guys did, it was like $4 billion worth of equipment that year. And at the time, it was the vendor to beat. I think Cisco's, proved its mettle. It's still chugging away. Nortel didn't like that. This was my favorite quote ever from a competitor. We're not going to lose our market position in optics. Cisco still can't spell optics. This was the quote from a president at Nortel. Now, if you think about it, optics, look at the word optics. Every letter in the word optics, you could pull out those, Cisco has every letter in the word optics. That was what I was trying to say, if you look at it. Not the T, of course, but it has all the letters. Cisco invested a lot. We did a very aggressive, we're the guys that do IP plus optical. Dennis Miller was hired. I wish I could have seen it. I heard it was hilarious. So he did a corporate event in front of a bunch of customers where he did the mega launch of IP plus optical. That was back, what does that say, 2001, I think? Early 2001. There you go, thank you. So the future. Back in 2005, when we looked at the market, because the access, the way you get costs out of a product is you don't have something do everything. So there was a bit of a thing where less flexibility means we can do micro MSPPs. Let's just do something that's optimized around packets and Ethernet. And so we developed micro MSPPs. The industry did, that is, as a lower cost approach to do things in the access. Electronic mandate, electronic economics said, MSPPs on a chip. So the guy at Sarin that founded the company founded Crimson Microsystems, and they toyed with MSPPs on a chip. And what was interesting, we saw with those two bullets, we went from refrigerator-sized equipment, taller than me, to shelf equipment, to in 2005, you had an entire MSPP on a card, right? And what Crimson was wrestling to do and others is, how do I get an entire MSPP on a chip? Okay? As it turns out, the market shifted. We went to DWDM. We went to, we got rid of all circuits and moved to packets kind of thing. So that's what was happening. So those initiatives didn't take off as much as we had hoped back then. But that's what happens when you put a lot of smart people, a lot of engineers to work on these problems. You get things reduced in size, power, and all that stuff. Okay, the future is seen from now, 2015. All circuits have been replaced by packets pretty much. I keep getting calls from AT&T. Please switch to UVerse. You don't need to use your old DSL modem anymore. They're trying to get rid of my copper line. Why? Because they want to get everything on packets. My phone line, I always tease them because I sort of know what they're up to. I said, no, I want my copper line because if there's a power outage, I can still, the dial tone has to come from the central office. I still have a phone, not a phone that's fancy, but an old phone you plug in with the RG45 jack. And in a power outage, my phone will work. But with packets and optics, you won't have that. And that's the way the world's going. All the MSPPs, this thing you see here has essentially been replaced by these packet optical transport systems I mentioned by companies that are in Sarin. But what was significant is IP plus optics happened as we foresaw would happen. We didn't predict all the details, but we knew that would happen. The electrical switching systems are disappearing. They're going towards optical switching because, as someone mentioned, 100 gig, 400 gig terabits. You want to be you're not going to convert those back to electrical, all that capacity, and then switch. So you want to switch optically. And then fiber economics, it supports wireless backhaul in the cloud. How? Well, if you have all of these phones streaming video to the cell towers, you can't have copper wires anymore running it back, or Ethernet cables running it back from the cell towers. You need optics. So now you've got fiber to the tower is what's happening. And that's where the bottleneck is, and that's where it's being broken. And that can be directly to the towers or Wi-Fi. Bring back all these Wi-Fi spots from stadiums on fiber. It's being done. So, impact of Sarin on the 454. What did it do? It brought, this little thing brought Sarin into the optical space. It defined this whole new class of products that became the new class that other vendors also did. It stimulated a whole bunch of startups. I mean, Don Green was on our board at Sarin, and he founded other companies here in Sonoma County. Turin Networks was one of them. Don Green founded that one, and that was headed up by a number of locals as well. And they had a long run as well before they were acquired. We also delayed the widespread adoption of Metro WDM, which today are these POTS product I was mentioning. We essentially replaced the legacy Sonnet products. So you had the Sonnet type products, you had ours, now you have POTS. There's a constant evolution as technology evolves and standards change. We accelerated fiber penetration to the towers, as I mentioned, and to the homes, to the curbs. Wherever fiber goes, you get a lot of bandwidth, more so even than coax cable. We cap these cross connects. The switching now is integrated within these platforms, whether it's electrical or optical. We validated a new manufacturing model. It was quite innovative to not have your own manufacturing. All those other vendors I showed you had in-house manufacturing. I used to work at Nortel Networks, and they had a huge plant in Montreal, Canada, and they owned the manufacturing. We outsourced it, so they don't have to deal with the problems of manufacturing, just with design, engineering, marketing, and sales. And we established the importance of simple, fast, and easy. Make it easy for the customers to do business with you. So as you, as engineers, are designing a product or coming up with a solution, make sure it's easy for the user to take advantage of. I was talking to a lady before it started. Is she still here? And she said that she didn't use this kind of technology until the iPod came out because it was so easy to use. That was back in the day. Okay, and then of course, with Dennis Miller's help, we reshaped Cisco's product direction from IP-centric to IP plus optical. Now in terms of the legacy in Sonoma County, I just want to touch on a couple of these. First, philanthropy and support of the university here. The team has been very excited in supporting the university's thrust to get a technical program, and that was driven by guys like Saeed back there. Sarin also and others in Telecom Valley helped change the direction of the telecom industry by helping optical transport evolve much more quickly than it would have if Sarin wasn't here. And the software that we used, leveraging web-based technologies to manage products, that essentially enabled the software thinking that has led to the cloud. You keep hearing about it. Store all your stuff in the cloud. The kind of thinking that people like this had in Sonoma County drove what's going on now. And then, of course, people love work, and so they spawned, a lot of the ex-Sarin people spawned a number of startup businesses in Sonoma County. Okay? And I like Saeed's, I sort of paraphrased Saeed, what we talked about in our interview back when, before I published the book. He observed that Sarin helped to transform the culture of SSU, just as the little upstart startup helped to transform Cisco. And what I mean by that is SSU is primarily an arts-focused institution until this technical discipline got started. So you guys are at the leading edge of growing the technology capabilities of this university. So congrats to you on that. So let's consider a couple of the philanthropic pursuits. First, Don Green, who was our chairman at Sarin, and his wife established the Green Music Center. You've probably seen it or been in it or heard a concert. Him and a number of folks worked up $145 million in donations, and that brought that world-class music facility to Sonoma County. And as I understand it from your paper, I thought I had a copy of it here somewhere, you guys now want an amphitheater, so it looks like music's in the blood here as well.
This one now.
That one, yeah, I read that in that one, that's it, thank you. The Sarin 6 brought the Sarin Engineering Science Complex to fruition. With Saeed there's 6 gentlemen that donated $4 million of their money to help this vision to be realized about a technical discipline here. So great job in all those fights that you and others did to make it happen.
It was fun.
Fun, in quotes, yes. Startups in Sonoma County. This is a sampling of some of the ones I've either worked with or I know the guys would have you. The ones in the top right, is that sort of purple, Calix, Sign, and Enphase Energy. All of them have since gone public with successful IPOs. And they're always asking, what can I get SSU to help me with? And of course, it's talent. So they're looking for people like you. Brandel and Pocket Radar. I know Pocket Radar is up in Santa Rosa. Brandel, I think, is also in Petaluma. That company, they have not gone public. They've stayed private, but they're always looking for engineers. The 3 in the bottom left, sort of the reddish ones there, Camus Crimson Microsystems and Karen Systems, they didn't survive, but they all had engineers pushing what they worked on back in the day. So again, there's this thriving community. Some work, some don't. Just gotta bust your hump and you can make it happen. So in terms of engineering, this is what companies like this need. Obviously mechanical engineering, you need a really good set of mechanical engineering to come up with the connections, the thermal profile. This actually came with a fan assembly. You had to draw the heat up because this thing would be like a hot oven if you didn't have it cooled. Electromagnetic interference. You have to have people knowledgeable in that to make sure that it meets standards in an office, because if you got hundreds of these things, you can't have it radiating microwaves everywhere. So EMI is a big deal. So the mechanical piece is huge. Electrical engineering with the folks in electronics and communications. Hardware, software, I heard discussions about, if you want to be in hardware, here's, some people to talk to. Computer science, system verification and test, both in-house when you're integrating your own hardware and software, when you're integrating it to be interoperable with other vendors' equipment, that's a big deal, or when you're out with the customers doing field trials or doing system lineup and test. You need engineers for all those kinds of functions. And then, of course, the optical engineering piece. Noise figures, and there's all kinds of cool things there. Bit error rate, waterfall curves, and companies like Keysight make all this cool gear so you can actually test and characterize these kinds of products. This is essentially, I think you'll see this on the SSU website, but what I'm keen on, I'm not going to read it all, is these companies want engineers, folks like yourself that solve engineering problems, are able to work on teams. You've got to be receptive to working with others. Very few people work in isolation as geniuses and produce something. There's a lot of teamwork. Ethical responsibility. I've seen colleagues, and one of my managers a long time ago, they would cheat on their expenses. How unethical. Anyways, they were caught. They're eventually all fired. Don't do stupid things like that, right? Ethical responsibility. Always do the right thing. Communicate effectively. If you got an idea, the best thing are the brainstorming sessions. You get the whiteboard and you get a number of folks and you brainstorm. What's the best way to tackle this problem? Or if the problem seems insurmountable, can you break down the problem into a number of smaller problems and then tackle it? So the communication part is huge. Once you get your degree, you're not done. You've got to be lifelong learners. So one of the things I've enjoyed is working with the IEEE over the years. It's an association, and you can meet about new topics and stuff that can be publicly disclosed, not patents and secrets. So you want to be a lifelong learner and always learn more so you can hone your craft in the engineering field. And last but not least, have a great attitude. People will not want to work with you if you're Eeyore in Winnie the Pooh. So if you can, maybe Tigger's too much, but after some coffee and some Mountain Dews, I used to have coffee in the morning, Mountain Dew in the afternoon, and it kept you going. So have a great attitude. Okay. So in summary, the Sarin company, the Sarin 454, was a great product idea that changed the status quo of this optical transport industry. And the parallels, if I've done some of the studies, if you do a study, it's just like the Apple's iPod. How Steve Jobs and Apple and the iPod changed the music industry, right? When's the last time you bought a CD? Has anyone bought a CD in the last month? Oh, okay, there has been some. All right. Usually this stuff's downloaded somehow. And I use iTunes myself, and I get some of the oldies they now have up. So, the MSPP market at the time, it dominated, and by 2006, it was the dominant way to deploy optical transport. Okay, it went to 51% in 2006. This innovation spawned category extensions, they call it. I can do, there was the technology to do MSPPs on a blade instead of a shelf. There were new markets. Let's do an optical switching platform. So that was all done. Innovation and utility. That means the customers, if they see that you're innovating and always trying to push the envelope, and by the way, they can use the product and it helps them achieve their goals, lower cost, less power, I can generate more, whatever they are, they will come after you, they will buy product from you. So innovation and utility ensures the customers accept what you do. And then last but not least, technology always, well I shouldn't say always, but I think always changes things for the better. And in this field it certainly did. And we all now have access to greater bandwidth because of the overall support for more bandwidth that's happened. You could not conceive of this product without having a lot of bandwidth in the access that could then be transported across. How could you update this software download, this product, without having a rugged optical infrastructure that allows that high bandwidth to be processed? A bit of a sad note in 2002 when things were tough, but I love the quote. In spite of the telecom meltdown in 2002, Jim Duffy, who I briefed a number of times on this technology back then, said that the MSPPs, the Sarin 454 he's referring to, and the MSSPs are one of the flickering stars in a telecom constellation that's gone dim over the past 18 months. So he was writing this when it was a tough time, when all these companies were going bankrupt for a bunch of reasons. And so MSPPs, even in the darkest hour, were the brightest stars at the time. So that was that was fun to do. So I think I went long. I apologize, but are there any questions that you may have, or comments or thoughts? Welcome them. Yes.
So when Sarin was started, was the picture that they were just going to build this one box and this was going to be their whole platform, or was it like a big idea that got whittled down to this one?
There was a bunch of big ideas. The architect, I'll say, is Paul Elliott, who worked with the founders, Jay Badar and Mike Hadfield, who's founded Sarin with Eric Cleland. And they whittled down, like you said, all these ideas to say, what do the customers need? And then we had guys like Terry Brown who were out on the road talking to these customers in those categories I showed you. And they said, we want, number one, the OC48 bit rate. That's the sweet spot. DS3s are our fastest growing thing. We got to fill them. Why? Because that's like chunks of 672 voice circuits. We may need Ethernet later, right? Because they knew packet was coming, but everything was circuit back then. We talked to the telecom guys versus the datacom guys. So they boiled it down to a platform that could scale in terms of any bit rate and, quote, any service interface, right? And they were asking for that for years. The other guys were ignoring them. I was at Northern Telecom, and they were organized around bit rates. There was a group for 12, a group for 3, a group for 48, a group everyone wanted to be in was the 192 group because that was new, right, engineering-wise. So they were organized around bit rates. And these guys says, no, let's do an architecture so you're organized around a bit rate that can scale. Because these center slots, they're called high-speed slots. They can take any plug-in, right? 12, 48, or 192. And the outside slots, I think there's 5 on either side, can take any kind of low-speed interface with or without protection. So it was architected from day one to provide that functionality. And then from there you extend it. Now, if a customer says, you know, I want to put this product on a customer premise, we ended up coming up with the baby brother of the 454 called the 327. By the way, any ideas why it's called a 454? Yep, big Chevy engine, big honking Chevy engine. All the horsepower you want under the hood. And this was the hood. So why was the baby brother called a 327? That guy knows.
Small block.
Yeah, there you go. She had the big block and the small block. That's why it was called that. By the way, why is it a purple color, the original product? Does anyone know Mike Hadfield? Does anyone know his favorite NFL football team? Correct. It's because it's by the way, it's the Viking purple. I mean, it's not completely because it, anyways. And this is the Starburst because it's fiber optics. And it's voice, data, and video on fiber. And the fiber's red. I mean, they had a lot of fun. So that's when you've had a long day, and you bring in some beers to work, which you can do at a startup, and you come up with what should we call this thing and what should we do. And that's what you do. Okay. Sorry, Steve.
How long did it take for those three people, Paul and Dave and Mike, when they came up with the idea, to then realize this? How long did it take?
They brainstormed in the fall of 1997. The first product came out for trials in 98, and it went in service on my wife's birthday, November 19th, 1998.
Wow.
So it was basically a year. Now, when it first came out, it didn't quite look as pretty. Right? The original shelf, it was all white, and they were field trials, and that was in the summer of 98. But the one that went with these colors and all, that was November 19th, 1998. The first one went in service. And everyone was scared to death because we were carrying real traffic. Someone's phone call, someone's internet sessions, that was on this thing. Right? And you never know, right? Things can happen. Yes?
Did they have a patent before they released the first product?
They did not have the patent, but they had filed patents.
Okay.
And I think they had something like 50-some patents by the time Cisco acquired them, either in process or they had gotten them. Yeah.
They get a lot of value.
Yeah, a lot of value for it. And one of the patents was, remember when I said that you could, you didn't have to drive to a site to configure it, so, right? There was this configuration called BLSR, bidirectional line switched ring. So say you got 4 nodes in a ring. This thing would auto-populate what they call the squelch tables. It would figure out how the traffic would be routed around the ring based on what you would enter on the GUI screen. Right? Think about it. Otherwise, you need to get in your truck and drive out to sites which could be separated by as much as 80 to 100 kilometers, right? 60, 70 miles apart. That takes a while. Why not just do it, hook it up, fire, do the slat, and then set up all the circuits remotely. And that's very important when you're trying to add circuits, add service after the fact. You don't want to visit these sites to change it. You want to do it, if you can, through software download, through point and click mouse activity. Okay. Yes?
So could you talk about just the rollout of functionality, starting with what you first delivered to the customer?
Be happy to. The first functionality was the configuration called DS3 to OC48. That required 4 plugins. That was a popular configuration. At the same time, concurrent, you could do OC12 with those DS3s. So that was essentially the first release in November 98. There was a dot release because there was a hue and cry for DS1 interfaces because you could connect digital loop carriers and stuff, right, in the access or in rural areas. And so the dot release brought out DS1. That was February of 99. Then the big release before Cisco got their hands on us was, release 2.0, and that had the Ethernet interfaces, right? You could do 10 gigabit E, 100 gigabit E, Ethernet and fast Ethernet. And then you could do 8 wavelengths of light, right? So you could then do what I call DWDM, more on the regional network side, less so than the metropolitan side. So that was the initial rollouts in 98, 99. And then from there, it just, under Cisco's guidance and their financial backing, there was a lot of programs going on at once. Yeah. So DS3, DS1, Ethernet. It supported the OC48 and then 12 and 3s. And primarily 3s weren't used for backbone. 3s were usually, because we did, I think this is it, a 4-port OC3, and that was considered a tributary. So it could connect ATM, because this does OC3 or OC3C, the concatenated load, so it could do either telephony-based OC3 or ATM or frame relay or whatever, anything that's a concatenated load that was at 155 megabits. Okay. So it was quite a bit on day one.
All right. I bet a lot of you have more questions to ask. I didn't ask you to do that in the pizza. First of all, let me ask those of you who are taking the data network course at 6 o'clock. Let's meet in the room across so that other people can stay with the speaker because he has a lot of reading. I really enjoyed, I'm sure you all did, the talk. It was so interesting for me and so on. Especially make sure to those of you who write the report, in your report, you know, the last, there was one slide there that was a lot of good advice as an engineer, for an engineer when you go to the market and so on. Use those because they are really true. What he said, they are all true, and let's follow. Okay, so let's give him a hand.